Lesson 18. Reacting to input with state. 1. Reacting to input with state. Let's start with the main idea. React offers a declarative way to control what appears on the screen. Instead of directly changing individual parts of the user interface, you describe the possible states your component can be in, and React handles the transitions between them when the user interacts with your app. This is a powerful shift, because it mirrors the way designers think. They imagine screens in terms of states, not in terms of individual commands. 2. How declarative UI compares to imperative. When you design an interaction, you think about what happens when the user does something, for example, filling out a form or pressing a button. Let's take a simple form as an example. When the user types something, the submit button becomes enabled. When the user submits the form, everything is temporarily disabled and a loading indicator appears. If the network request succeeds, the form disappears and a "thank you" message appears. If the request fails, an error message appears, and the form becomes active again. In imperative programming, you'd write instructions for every single step: when to enable, when to disable, when to show or hide elements. You're giving the computer exact orders for what to do and when. It's like sitting in the passenger seat and giving a nervous driver turn-by-turn directions: turn left here, slow down there, take that exit. If you make a mistake, you end up in the wrong place. This approach works fine for small examples, but as the interface grows more complex, managing all those instructions becomes a nightmare. Adding a new button or interaction might break something you didn't expect. React was built to fix that problem. In React, you don't command the interface step by step. Instead, you describe what the UI should look like in each situation, and React figures out how to get there. It's like getting into a taxi and saying, "Take me to the airport." You describe the destination, and React, like the driver, decides the route. 3. Thinking about UI declaratively. Let's break down the process of thinking in this declarative way. You'll follow 5 steps. Step 1. Identify your component's different visual states. First, you need to list all the distinct visual states your component can display. For a form, those might be: empty, the submit button is disabled; typing, the user is entering text, and the submit button is enabled; submitting, the form is disabled, and a spinner appears; success, the form is hidden, and a success message appears; error, the form is shown again with an error message. This step is very similar to how designers create mockups for each possible view. Before writing logic, you can even create visual mocks of each state. For example, a version of the component that looks like success, another that looks like error, and so on. Mocking helps you focus on design before worrying about the mechanics. Step 2. Determine what triggers those state changes. Once you know your visual states, figure out what causes them to change. There are 2 types of triggers: human inputs, like clicking, typing, or navigating, and computer inputs, like receiving a network response, finishing a timeout, or loading an image. In the form example, when the user starts typing, the state changes from empty to typing. When the user clicks submit, the state changes to submitting. When the server replies successfully, the state becomes success. And if the server replies with an error, the state becomes error. It helps to sketch a diagram showing all these states and the arrows connecting them. Doing that early lets you spot missing cases and logic errors before you ever write a line of code. Step 3. Represent the state in memory. Now that you know which visual states exist, you need to store them in memory. In React, this is done using state variables. You'll need to store the text the user entered, any error messages, and the overall status. For instance, whether the form is typing, submitting, or successful. The key is to keep it simple. Each state variable is like a moving part. The more you have, the higher the chance of something breaking. So start small, and only add what's absolutely necessary. And if the server replies with an error, the state becomes error. It helps to sketch a diagram showing all these states and the arrows connecting them. Doing that early lets you spot missing cases and logic errors before you ever write a line of code. Step 4. Remove any non-essential state variables. After your first pass, look for redundancy. Ask yourself a few questions. Does this state create a contradiction? For example, can typing and submitting both be true? If yes, that's a sign you need to simplify. Is this piece of information already represented somewhere else? Can I infer this from another variable instead of storing it separately? By combining and cleaning up state, you avoid bugs that come from impossible or inconsistent situations. In our example, after simplification, only 3 state variables are essential: the user's answer, the error message, and the current status of the form. That's it, clean, clear, and easy to reason about. Step 5. Connect the event handlers to update the state. Finally, you connect everything. Your event handlers, for typing, submitting, or handling responses, will simply update the state. React will automatically re-render the component to match the new state. At this point, you've stopped telling the interface how to change. You're just describing what it should look like depending on the current state. Even though this approach may take a few more lines of code, it's far more reliable and easier to extend. If you ever want to add a new visual state, you can do it without breaking the rest. 4. Recap. Declarative programming means describing the UI for each possible state rather than manually updating individual parts of the interface. When building a component, follow this process. Identify all the visual states. Determine what triggers those state changes, both from human and computer inputs. Represent those states in memory using state variables. Remove any non-essential or redundant pieces of state to keep it simple and consistent. Connect your event handlers so that user actions and system events update the state. By following these principles, you make your components easier to reason about, more predictable, and much more resilient to future changes.